I'm not aware of a way that the calculator will do prime factorization, at least not these ones, which is okay. So we're going to split this up into two parts, right? We got prime, so that's prime numbers that we're talking about, and then factorization. So factorization is just figuring out what numbers multiply together to get us a different number, right? Or a number that we're looking for. So prime factorization would be numbers that we multiply together that are prime to give us whatever number we're looking for. Now, that didn't have to make sense right now, but hopefully it will by the time we finish the lesson. So starting off, any number, prime numbers. They're any number greater than 1, but it's only divisible by itself and 1. So that'd be, for example, like 2, right? 2 is only divisible by 1 in itself. Same with 5, and even 19, right? Like, could you divide 19 by 3 or 2 or 5 or something like that? And no, you couldn't. You couldn't divide it by 13 or 15 or 17. It's only divisible by itself and 1 to get whole values. Now, if you're like, well, I could divide it by other things and get decimals, okay, that you could, but we need to get whole values out of this stuff, okay? On the homework, you guys are going to have to be identifying if numbers are composite or prime. That's just to start out with. So for these ones, again, we're just determining if these numbers are prime or composite. So when we're determining if they are prime or composite, we just really need to ask, if I took a number like we see in this set, is it divisible by another number other than 1 or itself? And that's what we want you guys to figure out. So take, 30 seconds. And just see if you can figure out if these numbers are prime or composite. Alright, 30 seconds, go. All numbers are divisible by 1 in itself, so they're at least prime, but if they're composite, of course they wouldn't be prime anymore. So we're not really looking to divide any of these by themselves. So let's just start with 4, right? Could I divide 4 by anything other than 1 in itself? And the answer to that is yes. Of course, I could divide 4 by 2. And 2 times 2 is 4, so that works, right? So there's another value that I could divide 4 by other than 1 in itself to get another whole value. So this one, we'll say it is composite. Composite. There we go. 1. Well, is 1 prime or is it composite? Excuse me. Well, remember from the, I guess that's a formal definition, is a prime number has to be greater than 1. Well, 1 is not greater than 1. And composite numbers also have to be greater than 1. So as it turns out, 1, it's not either prime or composite. It's just neither. So that one was kind of a trick question, but I think some of you may see 1 on the homework, so it's just neither, okay? I think I spelled neither right. Isn't that one of those I before E things?
You did.
Oh, thank you, good. I worry. 2, though. 2, it was on the list for prime numbers, so you could have just looked at the list and said, well, I can see it's on the list for prime numbers. Now, 2 is divisible by 2, but 2 is itself, right? So it's only divisible by 1 and itself. By the way, any number is divisible by 1 because it's the identity property for division. 27. This is an odd number, and that's important to keep in mind if it's odd or even. But 27, I know, is divisible not only by 9, but also by 3, which means that it is composite. So I'll just take this composite. Let's see if I can... There we go. Bam. Composite right there, right? What about 13? Well, again, 13 was on the list. And you could run through all the values less than 13 and just see if it's divisible by any of them. And it is not. So 13 is considered to be prime as well. So we'll show that one as prime. Well, what about 87? 87 is a kind of a weird number. It's not even, so I know it's not divisible by 2. But what else is it possibly divisible by? Well, maybe 9. Well, it's not divisible by 9 because multiples of 9, you know, that'd be 81 and then 90, so it's not divisible by 9. What about 6? Nah, I don't know of any multiples of 6 that have a one place value of 7. And it's not divisible by 2. Maybe it's divisible by 7, right? Well, no, it's not divisible by 7. As it turns out, 87 is divisible by 3. And the way that I know this, we'll actually find out in the next slide. Let me label it for composite. So, how do I know that 87 is divisible by 3? It just comes from divisibility rules, you guys. So, numbers that are divisible by 3, and that was 87, right? So, a number like 87, let's see if I can write that better. 87. Well, if a number is divisible by 3, again, that's evenly, I would say the sum of the digits has to be divisible by 3. What we mean by the sum of the digits is you take the 8 and the 7, and you add them together, so that's the digits. 8 plus 7 is 15. And I know 15 is divisible by 3, right? Because 15 divided by 3 is 5. So, I know that 87 is divisible by 3, which would make it composite. Okay, so other divisibility rules, 2 is a pretty easy one because any even number, so if it has in its one place value a 2, 4, 6, 8, or 0, then it is even automatically, okay, and it's automatically composite. And the next one that we really want you guys to remember is the divisibility rules by 5. Now 0, it falls in the even category, but if in the ones place value you got a 5 or a 0, then it's automatically divisible by 5, okay? Automatically, and that's true for the 2's as well, for 2, 4, 6, 8, or 0. Again, 3 is a little bit different, a little bit more complicated. You could say you got to add those numbers and then see if that new number is divisible by 3. Now, if, like we got the 15 for that divisibility rule by 3 on this one for 87, but let's say that it was a bigger number, like maybe, I don't know, 615. Well, I'm not familiar with my multiplication tables up to 615, so you could just re-add those numbers together to see if that new number is divisible by 3. Okay, so you can continue this process of adding the digits to see if those numbers are divisible by 15. By 3. To see if the divisibility rule by 3 works. Okay. Maybe I made that more complicated than it should be. So divisibility rules by 7, 11, or 13, or 17. We shouldn't see any numbers higher than that. But if you don't see them divisible by these 3, you may want to try 7, 11, 13, and 17. But in that case, I'm just using a calculator to see if it's divisible by these ones. Alright, so divisibility rules help us to determine if numbers are composite or prime. On the other hand, though, they're going to help us with factoring as well. So values that a number is divisible by, again, when we multiply all the factors of a number, we should get the number, okay? Factoring, and just on a side note, factoring is an inverse property for distribution. I don't think we get into factoring, maybe we do, other than prime factors. So values that a number is divisible by, again, just if I were to kind of invert that statement, I would say it's numbers that you multiply together to get a specific number, okay? So again, prime factorization is just kind of combining the two. You should only have prime numbers in a prime factorization, but they need to be factors, right? So whatever we need to be able to multiply all the prime numbers that are factors of that original number to get the new number, that number that we're looking for. Now, if any of the values repeat, we're going to use exponents. And on the homework, it may say use exponents when necessary. It may not on some of the problems. But remember, if you see repeated values, it's all multiplication, which is why we use exponents. So this first one, find the prime factorization of 24. Okay, so, and some of you guys have different strategies for finding prime factors, okay? One of the main ones that I use is what we call a tree, a factor tree. And that's where I take 24, and the first thing I would do is look to split 24 up into two values that I can multiply together to get 24. Now there's lots of values you can multiply to get 24. You could say 2 and 12, and that would work. You could say 3 and 8, and that would work. You could say 4 and 6, and that would work as well. It doesn't matter which one you use, just don't use one in itself. Otherwise, you could continue this tree forever. So I'm just going to choose, 3 and 8, okay? Now, with 3 times 8, I would get 24, okay? So again, that's how this factor tree is working. But with those two values that I just split up 24 into, 3 and 8, I need to see if one of these is prime. And if one is prime, I'm just gonna circle it. Okay, I'll do a better circle than that. There we go. So 3 is prime, 8 is not because it's even. So I know for sure I can split 8 up into two other factors. Now I'm just using factor pairs. Some of you guys would say, I already know what the prime factors of 8 is. Okay, that's great. But I'm trying to use the factor tree, which should split these up into pairs as we go. So 8, I would split that up into 4 and 2. Okay, now 2 is prime. 4, on the other hand, is even. So I should be able to split 4 up into 2 more prime factors, which is just 2 times 2. And it's okay if you get repeating numbers, right? Because we're going to use exponents to represent these repeating numbers. So I have the 3. I'm just looking at all my circled numbers. I've got a 3, and then I've got a 2, and a 2, and a 2. And all these are being multiplied together. Now, this wouldn't be considered fully simplified until we use exponents to simplify, okay? So I've got a 3. I've only got one of the 3, so I don't need to use an exponent for it. But the 2's I do need to use an exponent for. So it's a base 2 with an exponent of 3, because it's 3 2's multiplied together. And when I combine these, I should get 24. Now I would check. I would go to my calculator and I would type that in. 3 times 2. And for my calculator, on the Casios, I think it's like a y to the power of x button. It looks kind of like this, I think. I could have that backwards, but for the TIs, you're going to be looking at...
that's correct.
Oh, good. On the TIs, you're looking for this button, and that would be a button right there. So I can see by putting that in my calculator, which I just did, I get 24 right there. Bam. All right, find the prime factorization of 91. Okay. Well, 91, right? So I'm going to look at the 3 main ones. The divisibility rules that we looked at. So 2, right? It needs to be even. Well, I got a 1 in the 1's place, so it's not even. It's odd. So I know it's not divisible by 2. Okay, it doesn't end in 0 or 5, so I know it's not divisible by 5. If I add these two numbers, 9 and 1, I get 10. 10 is not divisible by 3 either. So I just need to check and see if it's divisible by maybe 7, 13, 11, or I think, what was the other one? 17. So I'm going to take 91. Again, I'm just using my calculator to do this. 91 divided by, let's say, 7 and see what we get. Bam, 13. So right there, I can see that 91 is divisible by 7. Well, it would be 7 times 13. Well, 7 is prime, so there's a prime number. As it turns out, 13 is also prime. So 91 is just the multiplication of 2 prime numbers, 7 and 13. And that would be my answer for this one. So again, if the 3 basic rules don't work, the rules for the divisibility rules, 2, 3, 5, just check 7, and if we said, well, I'm going to start with 13, then it would work. Like if I went to my calculator and did 91 divided by 11, we kind of expect you guys to know this one. See how it gives me a decimal number there in my calculator, so I know it wouldn't work. And same with even 17, right? Like 91 divided by 17 gives me a decimal number, so I know it doesn't work. I wouldn't expect to see anything over 17, but I'm not going to say that you definitely won't. Alright, you guys take 30 seconds and see if you can find the prime factorization of 117, alright? 30 seconds, go. Alright, now, hopefully you guys have that done. Again, if you're still working, just finish it up and then check your work with what we get. You may look at 117, and I want to say on the homework it does happen from time to time where it's going to ask you to do the prime factorization of a prime number. So if you guys find that a number is prime, you could always just try and write in the homework. It may be D and E. But in any case, this one may look like it is prime. Almost particularly because it's odd, right? In the ones place we have an odd number. But this one is, hopefully you guys saw that it is divisible by 3, right? Because, again, 117, when I add these numbers together, I get 9. And I know that 9 is divisible by 3. So 117 divided by 3. Now, I don't know what I'd multiply 3 by to get 117. So I'm going to go to the calculator, right? 117, it's coming up there. 117 divided by 3, right? And again, I should get a whole number out of that. Bam, 39. So there's my 3 there, which is prime. So I circle it. So I'm going to look at and see if I can find prime factors for 39. And again, I see 3 plus 9 is 12. 12 is divisible by 3, which means that 39 is also divisible by 3. So 39 divided by 3, right? So again, I just go to my calculator. 39 divided by 3, what do I get? 13. Well, we already seen in the list that 13 is prime. So my prime factorization right now, I got 3 times that 3 in purple times the 13. So it says use exponents when necessary. We see a use for exponents with the 3 times 3, base 3, exponent of 2. Bam. Got to multiply that by 13 though, you guys. Don't forget that last part. And this would be the answer. Yeah, the order shouldn't matter. So even on this problem here, if we had written it or typed it into the computer or the homework as 13 times 3 to the power of 2, it should still mark it correct. So 385, this one's a nice one because I can see in the ones place value of 5, which means that I know it's divisible by 5, right? And 5 is prime. And again, I'm not good with my multiplication tables of 5 up to 385, so in the calculator I would type 385 divided by 5, and that would tell me the other factor, which looks like it's 77. 77 is not prime. Hopefully we understand and know that it's divisible by 11. Well, that'd be 11 times 7, which are both prime. So the prime factorization for this one, 5 times 11 times 7, and just to expand on what we just went over at that last problem, is the order of this should not matter on the homework. And I want to say there's 6 different ways you could write it, but 7 times 5 times 11 would still work, or 11 times 5 times 7. Again, the order shouldn't matter for these. Now, the reason why we've gone over prime factorization, some of you guys may be wondering, and some of you guys may hate prime factorization. Usually a lot of students do. I don't know how bad the hatred is compared with fractions, but a lot of students hate prime factorization. But it becomes pretty important when we start to look at one of the methods for simplifying fractions specifically, okay? So keep in mind, I mean, you may feel like this is not really relevant right now, but it will be, okay?